In this demo, we will discuss about lazy pool on execution plan and its impact on the performance of the queries. I'm going to use AdventureWorks DW database for this demo. First, I'm going to alter the database AdventureWorks DW's compatibility mode from 2022 to 2019. I've done that. So now what I'm going to do, I'm going to create a table called table1 underscore temp. I'm using select star into, and table1 underscore temp basically gets its data from table1. Likewise, I'm going to create a table called table2 underscore temp. I'm going to use select star into here as well. And table2 underscore temp gets its data from table1. I'll be creating a primary key on column 1 for both table1 underscore temp and table2 underscore temp. I will enable statistics time and IO for this particular select query. Now what I'm going to do is like I'm basically going to select all rows from table 2 underscore temp, and then I will check for any matching rows as far as column 4 is concerned from table 1 underscore temp. But what I'll basically be doing is like I'll be joining table 1 underscore temp and table 2 underscore temp, and I'll be checking for the year as far as column 4 is concerned. That's the join condition here. And once I compare and get the data, I'll be taking the maximum year from maximum date from table 1 underscore temp, and then I will be comparing it with column 4 that is present in table 2 underscore temp, and that will basically give us the results back. So here basically what is happening, we are dealing with date column. Column 4 is a date column, and we are basically on the predicate stripping out the year from the date, and then once we have the matching rows using the group by, we are getting the maximum year for that particular data, and then we are comparing it with the data as far as table 2 underscore temp is concerned. So let me execute that. Once this query executes, we will look at the statistics data and also the execution plan, and then we will take it from there. This is taking close to 11 seconds. Let's execute it with the execution plan one more time. So this is supposed to take more than 10 seconds. Last time it took close to 11 seconds. Let's look at how much is it going to take this time. It's 13 seconds this time. Now, if I look at the execution plan, what I'm basically seeing is like I'm performing a cluster index scan on table 2 underscore temp and table 1 underscore temp. And if I look at the data there, what I'm basically doing is like I'm estimating all the rows on the table and reading everything and then returning that. And as far as table 1 underscore temp is concerned, I'm estimating close to 61 million rows, and I'm basically like reading close to 245 million. It's like too many rows to be frank. But remember, we basically have close to 118,000 rows on each of these tables. Now with the nested loops, when it is basically going through the information, and now that we have this lazy spool on the inner side of the nested loop, what I'm basically seeing is like it is getting ballooned up. The read that is happening is really high, because if you look at the estimated number of execution, it is close to 2067. And if I look at this data here, we are like estimating close to 118,000. That is the whole table, and then we are reading it and sending it across. And here, as far as the cluster index scan is concerned, we are like close to estimating 61 million rows, and the number of execution is also like very high. And estimated number of rows per execution is 29,000, but the estimated number of rows for all execution is like Very, very high with the nested loop and also with the row spool. What I'm understanding is like this is like really, really ballooning up. And now, if I look at the stats here, what I'm basically seeing is like I'm doing quite amount of logical reads on table one underscore temp. It is basically like um, um, it is 1182324. That's what I'm seeing. So what I'll do is like I will just note it down here and then compare it. Okay. So this is the starts details, and what I'm seeing is like table 2 temp, I'm doing 589 logical reads, but table 1 underscore temp scan count is 2067, and logical reads is 1182324. We have work table here. If we see here, we have sort operation, so also the spool operation, and we are basically using the work table for that. Now what I'm going to do is like I'm going to disable this spool operator. So I'm gonna use this particular hint, which is query trace on 8690, which basically disables the spool operator. Again, spool operator is not a bad thing. It is basically used to improve the performance when optimizer has to perform some temporary calculation that can be reused by other operators. In order to do it again and again, what it does is like it just performs it, puts it into the spool operator, and it can be reused by other operators. In this case, I just saw the spool operator, and I know like a spool operator on the inner side of the nested loop can be sometimes result in performance issue. So what I'm doing is like I'm enabling this trace flag 8690 to disable that. Now that I know like it's taking more than 45 seconds, what I'm going to do is like I'm going to stop it because I know this is not helping in my case. So what I'm going to do now, I'm going to rewrite this query and I'm going to check if that is going to help me. And if we look at the query one more time, what we basically doing is like we are basically looking at the data here. What we are doing is like we are basically stripping out the year on table one underscore temp and table two underscore temp, and basically what I'm doing is like we are comparing that year using the group by. We are getting the max value for column 4, and what is happening, this is a row by row search, like whatever we are doing, it is a row by row search. And further I looked at the data, and what I was able to see is like column 4 comma count star, or as far as table 1 underscore temp is concerned, let's group it by column 4. Yep. And let's do the same thing for let's do the same thing for table 2 underscore temp as well. And then we will order by count star descending, so that we will know which one has got more rows and things like that. And if I do that, what I'm able to see is like I'm able to see like 11 January 2024 has got close to 13,000 records. Now what I'll do one more thing is like I will do a select distinct from, we know that the data as far as table 1 underscore temp and table 2 underscore temp is one and the same because we got it from table 1. So both are same. So let's look at uh, table 1, and that should be same for table 2 underscore temp as well. So if I look at it here, I have close to 2067 distinct rows out of 118,000 rows, and at max like I will be getting 2067 rows as far as the maximum is concerned. But what is happening here is like I'm basically checking each and every row for this particular information and then comparing it with this column 4 as far as table 2 underscore temp is concerned. So now what I'm going to do is like I'm going to rewrite this query. I'm going to put this information into a temporary table where whatever information I have inside this subquery, I'm going to write it here, like I'm going to put it as select year of column 4 and comma max of column 4. I'm putting it into a table called table 1 underscore temp, getting it the information from table 1 underscore temp, because this is on the table 1 underscore temp, and then I'm grouping it by year of column 4. And then what I'm doing is like I'm joining table 2 and table 2 underscore temp and hash table that we have created here, and then I'm basically doing a join. So if I run this query, the query just completes. It returns close to 13,144 rows. And then if you look at the execution plan, it is like very sleek and it's not doing anything much. So if we look at this one, we are using an hash match, and then I can improve this query further by adding an non-cluster index. But just the rewrite, if you look at, like it has brought down the query performance from 14 or 15 seconds to some milliseconds. Yeah, so it is basically taking close to 47 plus 53, close to 100 milliseconds. Now what I'm doing here, I'm doing a table scan on the temporary table, and if you look at this, at max we were getting close to 4 rows, like instead of doing the search 1 row at a time, when I strip this out and put it as a temporary table, I just have 4 rows to compare with this table. And now here I'm comparing close to 118 rows. I'm estimating 118,000 rows, and then reading that, the whole table, and then returning that, and then the information passes through to the select operator. So what I'll do now, let me bring this query and then run this query side by side with this query, and then see how good these queries are. Like let's compare the performance of each of these queries. The first query gonna take close to 12 or 13 seconds to complete. The second query should be taking 100 milliseconds. Once the query completes, we will compare the execution plan and also the starts details. Now, if I look at the execution plan, I'm able to see that this execution plan is like sleek and small too. And this one we have a nested loops, and here we have an hash match. And if we look at the stats, what I'm able to see is, like, at least on the first query, I'm performing this many logical reads. But if I look at the second query, what I'm seeing is, like, on table 2 and table 1 underscore temp, I'm basically performing close to 572. This is like so many X improvement, and it's like several thousand times performing better. But yeah, a simple rewrite can really do some great wonders. It is just like we need to understand the business logic, and once we know the business logic, I think it will be very easy for us to rewrite the query and then really improve the performance. Here, what I'm basically doing is, like, I'm basically in order, instead of reading each and every row and getting the value for column 4, since it is a date, and I was able to see, like, at max we have close to 2057 distinct rows. What I felt is, like, even if it is going to be for one full century, it is going to have 100 maximum dates. So that's the reason what I've done is, like, I've stripped this query inside the in clause. I created it as a temporary table, and then I basically performed an inner join. So now we are able to see that these two queries are, after the rewrite, we are able to get great performance. But what we do now is, like, let's change the compatibility mode from 2019, that is 150, to 2022, which is 160. Let's change that, and then let's execute this particular query here. So this query, I'm going ahead with the old model. I'm not rewriting it. It is basically an in clause, and then I'm selecting the max column 4 from table 1 underscore temp, and I'm comparing the year from column 4 from table 1 underscore temp and table 2 underscore temp, and then I'm grouping it by year t1 dot column 4. So let's execute this query, and then let's see if it is going to take 12 seconds. Now, this query completes right away. And look at the execution plan. It is basically using not the same as the rewritten query, but if we see here, SQL 2022 addresses this particular problem, and it is able to come up with a better plan. This query completes again in 100 milliseconds. If you look at this, what I'm seeing is like without any rewrite, the query is performing better. Table 1 underscore temp is doing an 572 logical read, and table 2 underscore temp 2 performs 572 logical reads, and we are taking close to 109 milliseconds of duration. So that's power of SQL Server 2022, and this particular query even performs bad in 2019, and we had to rewrite it to perform better. But as far as 2022 is concerned, without any query rewrite, we are able to improve it to a greater extent. That's it for this video. Thanks for watching. Have a great day. Jai Hind.